Good day to all. The session is regarding intermediate chemistry. We already gone with so many series of sessions in this regard. So many valuable content which is pertaining that intermediate previous year. So many times repeated questions got collated over there. And you can go with the World of Competitive Chemistry channel so that you can access all the topics whatever we covered earlier, right? Now we entered into the session where intermediate chemistry can be used for entrance and competitive exams on the international floor, and the national level JE advanced JE mains conducted by National Testing Agency twice a year, that is for IIT and NIT admissions. NEET exam will be conducted for medical entrance examination, and Telangana and Andhra Pradesh government are conducting the exams which are pertaining with the MSET for admission into the BTech stream. In addition, government organizations are conducting government job competitive examinations where the general studies common question paper. The session will be very much helpful there also. Let's enter into our today's session. The starting of the session will be done by taking Nobel Prize in the year 2015 in the domain of chemistry will be considered. So detailed explanation will be provided regarding this chemistry Nobel laureates in the year 2015, what kind of invention accorded with this prestigious global recognized prize. The Nobel Prize in the chemistry 2015 was awarded jointly to Thomas Lindahl, Paul Modric, and Aziz Ansar for the mechanistic studies of DNA repair. This is again related with the biomolecules and living organism related application part is accorded with the Nobel Prize, and it is the kind of DNA repair. Genetic matter is the most important for driving all the metabolic activities and living organisms. Mainly, their characteristics build upon that genetic matter itself, DNA and RNA responsible in that regard. Deoxyribonucleic acid is the kind of collection of the old genetic codes, so that that is the most important characteristic. By means of any mutation or else any deviation or a deflection done in that DNA, that causes a genetic disorder which can't be curated by means of any therapy. There is no way for that kind of a treatment, so that there is a new pathway got invented in this regard. DNA repair was introduced by the scientists three together: Thomas Lindahl, Paul Modric, and Aziz Ansar. So mechanistic studies of DNA repair. So if you are going with the DNA repair, so that mutagenic mutations whatever present, so many genetic disorders get corrected, right? So the scientists are these are the scientists who contributed for the excellent work in the field of medical stream. Thomas Lindahl shared with 1/3 of the Nobel Prize. Paul Modric also having the same extent of contribution. As a Sankar is the scientist who three together accorded for the prestigious prize Nobel in the field of chemistry. Then there is a brief info regarding all three eminent scientists provided over here. Francis Crick Institute and Carley Hall Laboratory, Hertfordshire, United Kingdom, Thomas Lindahl belongs to. It is the address for Thomas Lindahl. And Paul Modric belongs to Harvard Hughes Medical Institute and the Duke University School of Medicine, Durham, NC, United States of America. So from this, the kind of contribution was made. As a Sankor, University of North Carolina, Chapel Hill, NC, United States of America. These three together explored the studies regarding this, the mechanistic studies of DNA repair. DNA stands for deoxyribonucleic acid. The cell's toolbox for DNA repair. They made a kind of tool in order to repair that DNA genetic matter infrastructure, right? The Nobel Prize in the Chemistry 2015 is awarded to Thomas Lindahl, Paul Modric, as a Sankar for having mapped at a molecular level how cells repair damaged DNA and safeguard the genetic information, right? Genetic information is very important. Based on that, only entire activities of the human will depends, right? That genetic preservation and procuration is possible by means of the new invention what they did. Their work has provided the fundamental knowledge of how living cell functions and what instance used for the development of new cancer treatment. This DNA therapy is mainly imbibed into the treatment of cancer. The mutagenic cells will be there and they causes carcinogenic activity, so that the curation for the cancer, this is the deadly or dreaded disease, we can say. All across the world, one by third of the ill diseases mainly caused by this most chronic disease, we can say cancer. Each day our DNA is damaged by UV radiation. Abnormal conditions, whatever the living organisms are in for, they are exposed for abnormal conditions for the longer period of time, so that there is a kind of fluctuation or else a conflict generated in that genetic code. Okay. For instance, UV radiation, free radicals, and other carcinogenic substances, whichever present in its vicinity, so that even without such external attacks, DNA molecule inherently unstable. So these are the main causes for the damage of DNA. If DNA damage, what happens? Genetic disorders are possible. Being DNA is a hereditary factor, those can be transmitted to next coming generations as well. That's the reason why this is very potential kind of research field they have chosen, and which was recognized by esteemed prize, right? Thousands of spontaneous changes to the cell genome occur on the daily basis. Furthermore, defects can also arise when DNA is copied during cell division, a process that occurs several million times every day in a human body, right? So whenever there is a defect is generated in the DNA, that kind of whatever defect originated can be multiplied for several times, because being DNA can be synthesized, new copies will be generated by means of cell division. There is a kind of reciprocation you can see. So everywhere, whatever defects you notice, that will be propagated. Propagation will be continued, so that entire human body will be affected by this damaged DNA, right? The reason our genetic material does not disintegrate into a complete chemical coils. In that, a host of molecular system continuously monitor and the repair DNA, so that there is a kind of natural repairing system in our body. Natural mechanistic tools are available which used to monitor and safeguard and even repair if damage is there. Certain extent we can do, but if that is beyond the whatever damage beyond the limit, what happens? We have to go for a specific methods of curation. So that part was made by Thomas Lindahl, Paul Modric, and Aziz Sanko together. So this is the kind of a new innovation in the field of cancer therapy, we can say, and moreover in the genetic matter curation or treatment. Nobel Prize in Chemistry 2015 awarded these pioneering scientists who have mapped how several of these repair systems function at the detailed molecular level, right? So that kind of contribution was made by these three scientists, especially in the genetic matter, that is most important a driving force for all the kind of activities of living organisms. So they worked upon, and that will be recognized by the esteemed Nobel Prize. So this is the way the entire description is provided for the Nobel Prize in the field of chemistry for the year 2015. Let's move on to the question number 2. This is the kind of device you can notice molecular. They are going to treat the damages whichever occurred. Double helical structure, everybody aware. Watson and Crick initially invented this helical structure of the DNA deoxyribonucleic acid, which is hereditary matter, genetic matter, very essential matter, right? Whatever damage you noticed, there is a kind of repair they are going to do. So this kind of technology got invented by these three scientists. Okay, so this is about DNA repairing system. And move on to question number 2, which is collected from Cambridge Assessment International Education. And here is the question: chloroethanoic acid. Chloroethanoic acid is formula is CH2ClCOOH, and its a sodium salt was taken. That is CH2ClCOONA can be used to make the buffer solution. The pK of the chloroethanoic acid is said to be 2.89. State what is meant by buffer solution. Explain how the solution of chloroethanoic acid and its sodium salt form a buffer solution. Use equations in your answer. So these two questions to be answered based on the concept, whatever they provided. In order to answer this one, first of all, we have to know the fundamental basic info regarding buffer. Buffer solution is nothing but the solution whose pH altered, not altered by means of any greater extent, either by the addition of a smaller quantity of acid or else base. So the pH remains constant by means of either addition of acid or base, that is said to be a buffer solution. Buffer is also defined as the solution reserve acidity and alkalinity, which resists the change of pH upon addition of small amount of acid and base. So for example, I'm taking acid solution whose pH is said to be 3.2. Let me go with the 3.2 pH solution in my hand, so that a few drops of acid is added, so that it remains as 3.2 only. And even small alkali is added, still that remains 3.2 only. That means so resisting that change in the pH and remains as the constant pH. Even you're adding acid or base from the external source, that solution is said to be buffer solution. And buffer solutions are available in the ranges of pH. That's the reason why we can categorize them as a buffer solution of acidic, buffer solution of basic, buffer solution of neutral, right? The criteria in order to synthesize the buffer solution is weak acid can be treated with its conjugate base, or else weak base can be treated with its conjugate acid, or else this is the way we can go for the solution preparation for the buffer: weak acid to conjugate base, or else weak base with the conjugate acid. In this manner, buffer solutions can be manufactured. So in that regard, so weak acid conjugate base is said to be acidic buffer, and whose a pH lays less than 7 only, around 4.5, that is also acidic buffer. But our chloroacetic acid and sodium chloroacetate is said to be having its pKa value as 2.89. Okay, so lesser the pKa value, greater the strength of the acid. Okay, so this is the way pKa value is provided with us. And in order to manufacture this acidic buffer, I'm taking chloroacetic acid and this sodium chloroacetate. Let me repeat: sodium chloroacetate and chloroacetic acid can be combined either by dripping an acid into the aqueous solution of salt, by measuring their pH using pH meter, making the aqueous solution acid with the same concentration of the salt solution. For example, you are taking 1 molar solution of chloroacetic acid and same 1 molar solution of sodium salt of chloroacetic acid can be taken. That equimolar ratio used to prepare this buffer solution. This is the way chloroacetic acid, sodium chloroacetate used to prepare the acidic buffer. So hopefully every question got answered with the detailed information, whatever mentioned in the option, question number 2. And let's move on to question number 3. The reagent that can selectively precipitate sulfide from the mixture of sulfide and sulfate in the aqueous solution is R. Okay, so here is the question which is related with the salt analysis. We can go with whenever the mixture of solutions we have, one is sulfide and either is sulfate. From this mixture, you have to specifically trace out this sulfide ion. So what is the suitable reagent they are asking for? Among all, copper chloride, barium chloride, lead acetate, sodium hexacyano, nitrosyl ferrate 3. So these many reagents are provided with you. Among all, which is exactly suitable for the identification of sulfide from the mixture of sulfide and sulfate, right? The correct answer is copper chloride. Copper chloride is the suitable reagent which used to identify the sulfide ion from the mixture of sulfide and sulfate. Okay, how can you get this? Let's go with the detailed explanation. Whenever copper chloride is treated with this mixture of sulfide and sulfate, it is very specific for the reaction with sulfide, but it is not reacting with sulfate. Copper sulfide will be precipitated at the bottom. So only the precipitation is possible for this copper sulfide. So you can clearly identify the precipitate formed in this manner. So obviously the given compound is said to be sulfide precipitated, and sulfate remains in the solution form, which is unreacted. Whenever barium chloride reacts with sodium sulfate, it able to give the white precipitate. So that the second option, barium chloride, is there. Whenever this barium chloride is added to this mixture, so it will react with sulfate, so that white precipitate of barium sulfate will be formed. So you can trace out this option, because our specification, our concentration is purely upon sulfide reaction, but not sulfate. Barium chloride reacted with sulfate, so that you can cancel out this option B. Move on to lead acetate. Lead acetate having tendency to react with sulfide and sulfate both. If it is reacted with sulfide, so that lead sulfide precipitate will be formed. At the same time, whenever sulfate is there in the solution, lead sulfate is also formed. Both the precipitates you can notice, so that it is not that suitable to trace out only sulfide. Separation of sulfide is not possible from this mixture, because lead acetate having natural chemical reactivity towards both the reagents in the equal way. Lead sulfite will be generated, lead sulfate also is generated, so that this can't be taken as the correct answer. And this sodium hexacyanonitrosyl ferrate 3 is called what? Sodium nitroprusside. Sodium nitroprusside is the reagent that is specific for the identification of sulfide. Okay, sodium nitroprusside, whenever treated with the sulfide ion, it used to generate sodium pentacyanonitrosyl ferrate 2. So here ferrate 3 now converted into ferrate 2. Here this thionitrosyl functional group will be generated. That means a sulfide is also added over. So sulfide is reacting with this nitroprusside. So that why can't we put the tick mark for this one? But we can't put tick mark for this one. Here they ask the question, precipitate formation is required, rather it is giving the colored solution. Colored solution will be formed. There is no precipitate form with this nitroprusside test. So that the correct answer, one and only one you noticed, is A. For question 3, option A is the correct answer. Whenever copper chloride treated with a mixture of sulfide and sulfate, specifically it will trace out the sulfide by the precipitation of copper sulfide. That is given in this equation, right? So this is the way question 3 will be answered. Move on to question number 4. Question number 4 again collected from 2016 JEE advanced question paper. Positive tolerance test is observed for. This is the what we can say qualitative analysis for the organic compounds. Here is the organic compound with aldehyde. Here also organic compound with aldehyde is provided. And here is the compound with hydroxy and ketonic functional group. You can notice here we have a double bond and the ketonic group. This is alpha beta unsaturated ketone. Among these many compounds, which are positive for tolerance test. Tolerance test is a specifically identification test for the aldehydes, and it can be prepared by taking silver nitrate first, dissolved in the sodium hydroxide. Silver oxide will be generated. Silver oxide now added with ammonia solution, so that ammonical silver nitrate solution will be prepared, which is designated as the tolerance reagent. Tolerance reagent chemical name is ammonical silver nitrate. Whenever it is added to aldehydic solution, because it is selective for aldehydes, being it is the mild oxidizing agent, only it will oxidize the aldehydes but not ketones. So though aldehydes and ketones are together, selectively react with aldehydes and unreactive ketones left over, because aldehydes whenever treated with this tolerance reagent and heated gently, you can notice the clear silver mirror on the walls of the test tube. Silver metal will be deposited on the walls of that test tube, so that you can identify this silver formation, and aldehyde identification is possible. So this is the way. Whenever aldehyde is treated with ammonical silver nitrate solution under alkaline conditions, whatever aldehyde is there, that specifically converted into carboxylic acid, and whatever silver salt is there, that turned into a metallic silver, so that you can notice that deposited on the walls of test tube. So it will be deposited as a mirror, and water ammonia will be escaped from that system, so that it is specific for the aldehydes. Ketones won't be reacted. Based on this kind of explanation part, you can clearly put a tick mark for where the aldehyde there, you can put a tick mark. Aldehyde is there in the option 1, aldehyde is there in the option 2 as well. And ketone you can discard, ketone you can discard. CD can be discarded, being ketones are higher molecules, they are complicated in nature. Being tolerance reagent is very mild oxidizing, it won't be reacted with them. Strong oxidizing agents when present, then you go with the reaction with the C and D as well. But now we have a tolerance reagent mild oxidizing. Aldehydes are specifically reacted. A and B can be positive towards a tolerance reagent. Silver mirror will be formed. This is the way. Question 4, option A and B are the correct answers. We move on to question number 5. Number of moles of ferrous oxalate oxidized by 1 mole of KMnO4 in the acidic medium. Right? It is the question given from the analytical part again. So we can say quantitative analysis question. This is the question given from volumetric quantitative analysis. And here, ferrous oxalate was taken and the KMnO4 solution was treated. Whenever this is the kind of reaction, we can say this is a part of redox reaction. Redox reaction stands for within the single reaction, one of the component oxidized, another component reduced simultaneously. The reaction is said to be redox. Ferrous oxalate will be oxidized and KMnO4 itself will be reduced. So that redox reaction, the number of moles of ferrous oxalate oxidized by 1 mole of KMnO4 in under acidic conditions to be answered. After getting that answer, we will go with the correct option will be KMnO4 upon treating with the ferrous oxalate solution and acidic conditions are maintained over there. So here the stoichiometric ratio can be taken as 2 exponential of KMnO4, 5 exponential of ferrous oxalate, and 16 H plus ions are required to be added so that Mn plus 2, K plus carbon dioxide and water will be generated. This is the balanced equation for this reaction. Whatever KMnO4 is taken, that KMnO4 is reacted with oxalate ions so that they converted into carbon dioxide. And here plus 7 will be turned into plus 2 so that 5 electrons get transferred over there. Remember that 5 electrons transferred. And 1 more mole of KMnO4 is required to neutralize this, to oxidize this ferrous ion. Ferrous ion is present and again we need 8 H plus ions over there. Ferrous again converted into what ions? Ferric ions. Okay, so being KMnO4 is the oxidizing agent, ferrous will be turned into ferric. And again here manganese will be turned into Mn plus 2. Plus 7 plus 2 conversion is possible. This is the way entire reaction is possible. Ferrous oxalate reacted in this manner. Okay. How many KMnO4 you are treating with? KMnO4 here 2 plus 1, total 3 KMnO4 molecules are reacted. Oh, and ferrous ions taken are 5. Equivalents of ferrous oxalate are 3 into 1. Equivalents of KMnO4 are 5. So that X is equal to 3 by 5. X is equal to 3 by 5. So 3 by 5 is mentioned in the option number 3. You have to make a correction over here. Sorry for the disturbance. 3 by 5 is the correct answer. You can put the tick mark for this one. Okay. Move on to question number 6, last question of the session. In the airbag on adiabatic expansion undergoes 5% increase in its volume. Percentage change in the pressure gamma is taken, airbag gamma is taken as 1.4. Gamma factor value is provided to you. Adiabatic expansion we are going with. Okay. So adiabatic expansion undergoes 5% increase in its volume. The percentage change in the pressure to be identified. The expected answer is 7. 5, 6, 9 are not correct answers. We have to check how can we get this 7. Okay. The correct option is 7%. PV to the power gamma is equal to K, constant. Okay. P gamma V gamma minus 1. dV plus dP. dP dot V gamma is equal to 0. This is the equation. So here we can put this equation for our answer, right? So here dP by P, this is the integration factor. All pressure factors are taken one side. Okay. dP by P is equal to minus gamma dV by V. So all pressure factors are taken left hand side, all volume factors are taken right hand side. Okay. dP by P is equal to minus gamma dV by V. Or else you can put dP by P into 100 is equal to minus gamma dV by V into 100. 100 multiplied both the sides so that the value remains the same. Okay. So that Here the gamma factor within the question they provided, within the problem only they provided, gamma of the air is taken as 1.4. So 1.4 is the gamma value, and 5% increase in the volume you noticed. Increase in the volume percentage, that's why multiplied with 100, you can understand this one. So that 5 percentage they mentioned, so that need not to mention all the things. 5 you can put over, so that 1.4 into 5 it will become 7% again, because 100 is there, no? So dp by p taken as the 100 multiplied with 100, so that you can put the percentage mark over here. Here one more important thing we have to understand is gamma value pure in case of adiabatic process. Gamma value purely depends upon the atomicity of that elements. Okay, for monoatomic gases, just like helium, noble gas, it will be gamma value will be taken as 5/3. In case of diatomic molecules like nitrogen and oxygen, the value taken is 7/5. Okay, so if 5/3 is there, you can get the value as 1.6. 7/5 is there, you can get the value as 1.4 gamma value. But they are saying we are taking air bag. Air is composed by around 70% of nitrogen and 20% of oxygen. So maximum content nitrogen oxygen only we have to go for the ratio 7/5. Hence air gamma value taken as 1.4, and being a volume increased by 5%, so that you can go for the multiplication. 7% is the correct answer, that is provided in the option number 3. By this, question number 6, option number 3 is the correct answer. We gone with the entire session with the real informative content of chemistry. Definitely, it will rise your interest towards the preparation of chemistry content in the extensive manner, and we will go with the new dimensions of chemistry. New content will be collated in the near future. Definitely, you will achieve whatever goal you are aspiring for. If you're continuously watching the channel, whatever series of lessons, series of sessions we are uploading, so that I'm sincerely requesting to like the channel, comment. So in order to comment, the question here is, the question we are posting here is, for the diatomic molecule. So for the diatomic molecule, we have the gamma value, right? So in that case, you can put the van der Waals equation only. I'm not going for any kind of question. So just to put the van der Waals equation as the question for the session in the comment box, so you can post a van der Waals equation over here, right? Share with those parents who are more serious about the examination, and subscribe the channel. We will go with the new content in the near future. Every day, then valuable content will be added. Those who are serious about the exams, definitely go with the entire session with the detailed notes. You have to make your own notes, so that it will be more fetching. You can get more content over here, right? Thank you very much for your patient listening. Thank you one and all.